All right, thanks for having me here. My name is Marcel, and today I'm talking about instrumenting and analyzing performance for web applications. Let me introduce myself here. I work at Google. The last 4 years I've been at YouTube, and this is my first year in ads. A couple of publications here. The Web Performance Daybook is actually one chapter I have, which is a compilation that our Stoyan Stefanov here put in the calendar, performance calendar. We run every year, the countdown for Christmas. We have every year like one post a day. It's very interesting. And they orally compiled, have one book. And then the second one I co-wrote with my teammate, Rick Viscomi and Andy Davis from UK. This is mostly in web page test, like guidance, how to install and how to use it and how to automate the process. I'll cover this a bit later. So in previous lives, I worked at Twitter and Yahoo. I was in charge of Wieslow. And before you guys ask, is in abandonware mode. So yeah, the reason maintaining a open source project is quite hard, especially if you're the only one doing everything. So the community didn't contribute much, but yeah, it's okay. It's still there. So feel free to fork and use it. This is the premise of my talk. So if you can measure, you can improve it. The reason I'm saying this, because I'm going to cover how to, usually I instrument my pages and how you analyze the data. And I'm not covering anything about how to log back to your servers or the server-side part of collecting, aggregating number, and providing this data for querying later. And nor I'm talking about web performance optimizations like techniques, details, how to fix. It's mostly like instrument and collect the data, and then you have your findings and how you can act on top of it. The first thing, you should understand well your metrics, what you're measuring in your page. So for that, I would say you got to be very intimate about the waterfall of your application. For instance, this is a random website I loaded, and you should be familiar with every single part of this waterfall chart. Not only the load part, but of course any action on top of what's happening. You should be able to picture in your mind by looking at the page, how is the waterfall? Like you can probably tell if you're very familiar with the page you're working on, like the number of requests that are made, why is low, why is fast, because you understand all the requests that are being done during this time. This is the most critical part to understand this part of your web application. Next step is pick your key metric. So it can be more than one, not necessarily one, but this is the hardest part to find one. This is very different from product to product. They have different meanings sometimes. I put here time to first foo. Foo can be anything, like the first image I display is important to my users, or a frame, an element. I think if I'm not wrong, Twitter had the time to first tweet, which is the most important part for the users to look at. Some call above default timing, which is when the whole viewport is already rendered, so it means the page is ready for the user, or time to interactive, when the page is actually interactive, so you can assume that the user are able to do something. Window unload, I would say avoid for now, because this is easy to cheat. You can build like a simple page and then put everything after the unload, so the page will be ridiculously fast, but not necessarily user are agreeing with you. But of course, it is better than nothing, especially if you design your page to follow the specs of the unload. You'll be fine to have that too. Other metrics, I say if you can afford it, by afford it I mean like if you can handle the number of logs are going to increase like by a bunch, especially if you add more. But I also say maybe it's good to start with try adding some metrics, extra metrics for a while, maybe for a sample of your population, see if it's useful or not, and then you can deprecate this metric. But it's good to understand that it's going to have an impact on your how you log all this stuff. Like storage may increase by a lot, especially depending on the size of your user base. And for this, the first metrics here I'm listing, redirect, DNS, TCP, and request responses, is useful to have that information so you can later chime in on the backend guys to see what's happening here. So there was some regression here. I noticed some spike, or maybe some browser. Only especially if you can narrow and break down by browser, see why this browser behaving like this and the others not. Sometimes there are regression, a new version of browsers. There are a lot of things you can learn when you track all this information. Of course, have first paint time and first contentful paint, new metrics as well. Understand how your users are actually getting something on their screen. First input delay is a kind of new metric. There's a nice write-up in this link here by the Chrome DevRel teams. It's measure the time your user try to interact with your page and how long it took for the actual page be responsive. So which is very interesting. JS, of course, you shouldn't measure every single of them, but maybe the critical ones to deliver something is good when you measure like timing, transfer, the time to evaluation, everything in there. DOM as well. There's a bunch of DOM timings available on the APIs, and a number of elements may help you understand when there is an increase, if there's some memory leak and you're not foreseeing, and how a new version is doubling the size of elements. And JS memory, I'll cover a bit more on JS memory because it's a Chrome-only metric for now. And of course, you have to add a bunch of dimensions to get to know your audience. This will be very helpful, especially when you're querying your logs. You're going to understand why something is happening. You're going to help you narrow down or break down by different dimensions, and you're going to understand why. Is this a particular page that's behaving slower? Is the whole thing? Or load type as well. Load type, maybe, is this a new tab that just opened, or it's just a page-to-page transition that's being loaded, or a full reload on a page? The cache level, of course, you can check if is the page loaded, everything was cached or not. So you can compare and make sure whatever you're tracking is trying to narrow and find the culprit for some potential regression you saw. And experiment as well. If you have like A/B testing, you should be able to correlate your A/B testing with whatever metric you're tracking. So it's essential to have that. User agent, browser as everything in location. It's ideal as well to have that. Of course, probably you have this in your logs. It's good to, again, find population bias is very interesting. Sometimes you see some regression, and then if you break down by either country or some certain type of browsers, you understand this is a low bandwidth country, that maybe this is the case. Visibility is also suggests using this too. The reason is visibility help you understand if the whole page was like in background or foreground, because there's a difference when measuring. Sometimes you put it all together, you may see a very sparse distribution here. So it's better to make sure you're counting if the page was, page probably won't even be rendered if it's not visible. Abandonment is also very important to track, especially if you have something that is computed like time to interactive, and then users suddenly abandon your page by either navigating away or clicking something. You should stop and tell, this is not like a full thing, it's just a partial, but sometimes it's good to have, and you can filter out from your logs. And pay attention to observer effect. This is in physics, when the observer impact what being observed. So this is suggests you, if you have especially some metrics that are very heavy to compute, it's going to take a while. So you don't want to push this payload to your user. So you better off try first, maybe in a small sample, and measure how long it's taking to compute that and see if it's worth doing. Just an example here is speed index. Not sure if you're familiar with that. It's a metric from web page test. But web page test, since it's a synthetic measurement, is able to do that from the browser screenshots. So this can be computed, so it's easy to compute the difference. Quickly here, the red image here shows like a bad speed index. It means like the page was starting loading, nothing was showing to the user. In the very end, everything suddenly appeared. And whereas the other case is the same page being loaded, but everything was loaded at first, and at the very end, the minimum part shows up, so a smaller index. Doing this for your user measurements is a bit tricky. It involves a lot of touch it down a lot, and you do a lot of, you touch the computed styles of everything in the viewport, and then you calculate that. And when I was, in my experience, when I was doing this, I noticed some in the order of magnitude of a few 100 milliseconds just to compute that. I did for a while. It wasn't very good numbers, so I decided to abandon that. But it was interesting to measure that. I don't want to just push this, but I did for a while for some users. This to start off, every time you're tracking your logging everything in your page, you should start from the time origin or navigation start. This will tell, it will be a timestamp when the navigation started. The reason I'm saying, seems a bit obvious, but I noticed like people tracking past this time, so ignore a bunch of other critical parts like redirects in the way. But this is where it should start, and every single metric you calculate is relative to this initial point, the T0. So in the ticks, every single measurement you do in your page can be either start end, or and then you can infer the duration by this delta, or the start end duration, depending on how useful the information is ready available for you. And the reason I say start end for every single metric that has a duration is because sometimes you have like questions like, why is happening from this metric to this metric. So you can compute like the delta between the end of a certain metric to the start of other metric. So it's very useful to keep both. Some exception, of course, things that has no duration, like first paint time, it just happened. There's no duration to compute that. And some first input delay, it's just a duration. You don't really care when actually started and ended. API, for that, Performance Now has a very accurate number of milliseconds with accuracy for 5 microseconds. There's a asterisk here because there's some, they reduced the precision lately in the browser because of the Spectrum meltdown attacks. And I suggest not using date now unless you support, of course, for legacy reasons, you have like a fallback for that. The API for that, user time API, is very useful for having your marks. Like let's say this is just a mark named foo. You can retrieve later, getting all the marks in there. You can retrieve by name. And the measurements, of course, is very interesting because you can pass 2 marks and compute for you the measures. And the cool thing about having this, because you have already in your browser the built-in mechanism to track everything. And plus, if you're using some browsers, they report this information when you're profiling. As I can show here, console does the same thing. It's useful for debugging. It does the same work as performance mark and measurements, and also both will show in your timeline, which is very useful, especially when you're correlating with your known flame chart. You can correlate and see when things are happening. So it's very useful to see all those reported in the timeline. Resources is a very critical part of when you're tracking, especially static content on your page and see when your JS is loaded. Everything is the same API. You can get by type or by name or use a performance observer. So if you need a better way if you don't want to rely on the browser built-in performance buffer, you can build your own and maybe narrow only for things that matter to you. And one thing here, keep in mind too, especially when dealing with static content host in a CDN, which is pretty common, to provide a time allow origin. So this will enable other properties of this API to provide like duration, transfer size. The reason for that is that for security reasons, they do that because it's to avoid, let's say, a competitor host one of your JS file on their page, and then it can later check what's the transfer size. If 0 means they already had in cache, so they visit my competitor, so let me show some ads for use my stuff. So this is to avoid that. It's a whitelist type of thing, just provide your own origin for that. Response header, this is a kind of a new thing on the API. You can provide, especially if you make like AJAX requests and you want to provide also how long it took, like a DB, or if read from the server-side cache, you can provide this information in either using your application or log back to your log so you can understand what's happening. You have like yet another dimension to look for. CPU, long tasks are any task that last longer than 50 milliseconds. And through Performance Observer, you can get this information. It's useful to calculate, especially when the page is being initialized, how long is the CPU is being hogged by the whole loading process. You can compute the time to interactive. It's very useful to understand. If you collect this information, you can understand like how long your page is being, spend a lot of time like on the CPU. In memory, the new Chrome, I think the newest release 69 has now more, it's more accurate and more frequent update. Before it was very bucketized and I think it was updated every 20 minutes, so it wasn't very useful. Right now you can track that. There's some restriction how you're measuring that as well. But now it's a very useful information to keep in mind, and especially for long living sessions. You have a session that lasts like a Gmail or something, you open there, so you can track over time how long it is being using your JS memory. And once you have everything, you have to log back to your servers. The Performance API also has this send beacon. It's actually a send beacon API. It's better than sending the traditional XHR, because XHR is, especially if you're sending your data before the page is downloaded, chances are this request won't be completed. So you probably lose this information. And a new image, you will fulfill, but the problem is you're delaying your user. Their experience is like being delayed just because you're sending something to the next page or next transition. So SendBeacon is well designed for that. And if I'm not wrong, there's even like retry mechanism. It's only going to send when it's available. You won't lose your information. And it works as a post, but you can use as a get like. You just ignore the payload on the data. So the example show here. And for support, I suggest using Can I Use, and if you have your browser share of your product, it's useful to combine these two. I think Can I Use has ways to integrate so you can track. So let's say I want to use Performance Observer. So what's the coverage you're going to have? If I do this now, and let's say in this case here, I have my users Internet Explorer, Firefox, and Chrome for this given reason, this given proportion here, I'll have like 89% of coverage. So maybe it's a good number, maybe it's not, but it's just up to you to say if it's okay to lose like 20% of tracking, but get some useful information. So it's, of course, really good to have. And of course, if something you don't like or wish you had, the WebPerf working group in W3C is very active. People always respond. It takes a while to land something in the browser online, but it's very useful. You know, people listen to everyone, opinions about some API, what's missing or it's not. And once you have everything in your you're logging everything, you always ask, should I just do for my users or should I do synthetic as well? Synthetic, I mean like having a benchmark, local, running this. I suggest both. First, because real user measurements is going to be your source of truth. So for your data, so that's your user telling how they're facing. You get aggregate data. Synthetic will be like a one single endpoint or maybe more, but it's going to be in a controlled environment, so you have data. The reason for synthetic is you have more information, because like in web page tests, you can get way more information than you can get in a real user, because there's no API. You can get information directly from the browser. And also you can you have historic information if you track for a while, and you can see stuff before you push to production. Like say if you're tracking your staging before push, so you have like a pre-release information, what may be causing that. That's my segment where I sell my book. So I suggest for having a synthetic, you have a web page test private instance. It's not hard to install. You have one, can even have one locally in your machine, but maybe increase for your company, have more in that. For that, have the nice book to suggest. The book covers not only the usage, but how to have your own private instance. In my part in particular, I cover more the API when I wrote the Node.js API wrapper. It's very useful for automating the processing continuous integration. And the one I cover in the very end is continuous monitoring. If you're doing this type of analysis, to log all your data. So now, assuming all the data you have is back in your server, the data is ready available for you, is the part that you analyze the logs. So first things first, I'm not a statistician. I can barely say this word properly. I'm just giving here some advice for things I found when I used. I probably don't use 1% of most data scientists would use that, but it's just easy to do. This is the interesting part about doing the analysis of the work. I remember when I became a computer scientist, I got really disappointed. As a child, I thought about, oh, one day I'll be a scientist, those with the lab coats and doing like discoveries in Eureka. They say, wait a minute, that's what I do usually, because when you analyze logs, you always find something funny. Say, why is this JS here taking longer than this one here? Oh, wait a minute, something's usually, chances are you're going to find something that smells, and then you're going to touch that, and you're going to end up like writing more instrumentation for that, and then repeat the cycle. So, or you're going to find something that you find a problem elsewhere. That's it's very common. So you touch something, you end up finding a problem elsewhere. This is a very interesting part of being a scientist doing science. And for that, yeah, you should keep in mind that the size of the population is very important. I mean, the sample of your population. If you can track all your population, good. You're dealing with facts, so this is good. So, but if not, if you cannot afford all the traffic, you better talk to your local statistician how to get a decent sample size and understand the caveats of having a small one or a big one, as long as it's representative of your population. The first thing when learning about a metric is to become very intimate about the distribution of this metric. Let's say foo here. I'm not sure what foo is, but I know how the distribution looks like. And then from that, you can infer, you see the shape of how your users are perceiving that information for you, and can either act on the long tail or try to push this long tail towards the center. So you find a better distribution and understand whatever you're doing, what's the impact is going to be. And once you have that, usually you're going to spend most of your time dealing with median, the 9th and 95th percentile. Perhaps if you care about like something to see how things are doing the very low, high speed things, you see the 25th percentile or 99th percentile. For the first input delay, this 99th percentile is really good to look, because you only care what's happening for those taking longer. I strongly suggest not, mean, you can use that, but it's very noisy. And it's the problem, especially in a distribution, depending on the size, is the problem of, let's say Jeff Bezos joined us here. So in average, we're all multi-billionaires, right? So that's a problem with that. So yeah, but if you really need to use that, or for some reason you want to choose, because the problem with percentile, you cannot sum percentile, but average you can. But I suggest using interquantile mean for that. You pretty much drop the top and bottom outliers at 25 percentile, and then you use that. It's not bad. I use for other reasons, but it's very useful as well. O'Reilly has some free resources in this link here, and this is one very quick book I read in one trip to LA once. It was 1 hour reading, pretty quick. As anomaly detection covers a bunch of the statistics, how to understand like time series, especially, and then it will give you some insight. Even touch in the very end some part about once you understand them all, how to make this and like put in your machine learning things, which is pretty trendy these days. Yeah, that's the interesting part. Once you have all your findings, how do you sell that? So selling to engineers is kind of a preaching to the choir, because if I just out of the blue here says, I found 50 milliseconds saving, let's do it. Chances are pretty much everyone is going to join me to do that, because I don't even have to say what is 50 milliseconds. But when dealing with people, not only engineers who can make decisions, it's like PMs or execs, they probably don't understand like what you're talking about the number, especially if you're talking about like milliseconds. So I don't know. So should you do that or not? It's very challenging. So you first understand their lingo. Whatever they talk business, you should understand well and try to correlate with that. Usually use like percentage, or talk about like, we're going to lose this amount of money if you save this amount. I never talk milliseconds with anyone when I talk to people who I can convince to do things. I just say, yeah, this is going to increase by X or percentage, or we're going to improve this audience somewhere, a number of users, everything. So it's a very important thing to learn this. Took me a while. I was trying to sell like millisecond, people don't buy that. And this, talking about business metrics, you got to understand as well that performance and business metrics, they not usually go side by side. Just an example here, here's a contrived example here, that time to foo can be anything, like maybe page load, and bar units. Units can be, I don't know, can be number of time spent on the website, monetary, how much is spending on their website for this or that, or time watching something. And then you come with a brilliant solution to drop like 3 of these images. So the page is now loading way faster. So, whoa, cool, kudos for foo. But then you look at the bar units, also reduced. So then it's a no-go. You should understand that whatever you're measuring, not because it's faster, necessarily means it's better. And then you have to explain why. Maybe in this case here, probably because you're offering less options to user has less option, I'm gonna click in less stuff. And before I leave you guys, this is my last thing here. Performance, when people say, they always, either they act on it when it's bad, or they think once you fix, you should go back to develop other stuff. But performance is an ongoing thing. There's no such thing as let's relax, it's gonna be okay. Unless everything freezes, like your code, your users stop like upgrading their browsers, and network is all the same. But other than that, it's always gonna fluctuate, and we're always gonna have a lot of work to do. Thank you.